We'll wait for 2 minutes and then we'll start. We'll wait for 2 minutes for everyone to join. Then we will start the class. Is my audio clear to everyone?
Yes, sir.
Okay. Okay. Okay, so let's start today's class. So today we will be solving some more signal processing based problems. So and along with that we will do Fourier series. So energy signal, power signal, Fourier series. These will be our main tasks today, main topics rather. Sorry, main topics today. So let me share my screen. Yeah. Okay. So uh, my screen is visible. I think not.
No, sir.
Uh, Now is it visible? Is it visible
Yes, sir.
now? Yeah. Okay. So let's start.
Yes, sir.
Mm, hmm. So the first question today is that which of the following best describes an energy signal? So what is an energy signal and what is a power signal? So here we have to take the concept of energy signal and power signal. So we will be going
The
into the
question is
question.
not visible, sir.
Uh,
It's your
I know. We will first describe what is energy signal and power signal, then we will go to the question. Okay? Because our topic is energy signal and power signal. So the topic is today is energy signal and power signal and Fourier series. So the question is which of the following best describes an energy signal? One second. Mhm. Which of the following best describes an energy signal? A signal with finite energy over all time, a signal with infinite energy over all time, a signal that repeats periodically, and a signal with power zero energy. So here I think you know the answer. So the answer will be, of course, the answer will be a signal with finite energy. But we will go into the reason as to why. So what is an energy signal and what is a power signal? So an energy signal is basically like a signal who has a finite energy. Signal with finite energy. That is simply the definition of energy signal. Signal with finite energy. So what is the energy of a signal? If you have a signal xt, let's say your signal is xt, then its energy ex will be given as integration. This is the no, not this. Sorry. Yeah, this will be the energy.
Minus infinity to infinity.
Yeah, minus infinity to infinity, the integration over x square. So basically, if this says signal is infinite, so it goes to infinity at some point, then of course the energy will be infinite. So the signal has to be bounded, and this integration has to converge. This integration has to converge. So, in one sense, this is like the area of the signal. So, if we have a finite signal, a bounded signal, like a signal like this, we can safely say
Sir,
this is an.
similarly, your
Uh-huh. What? Hello? Hello? Yes, please ask the question. Hello?
excuse me, sir, your writing is not visible, sir.
My writing is not visible?
Whatever you are writing on the board or the screen, that's not visible, sir.
Okay. 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 Uh, is it visible now?
No, sir. It is showing you are presenting, but it's not showing the question or whatever you are writing. Screen.
Okay. 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 Let me stop sharing and share again. Uh, this doesn't happen. Hmm. Now, can you see my screen? Can you see the question that is written?
No, sir.
That is very strange. Uh,
No.
let me try a few things once. Wait, wait. Hmm. Okay. I'll rejoin. Wait. Is it showing now? Hello? Is it showing now? Hello?
No,
Please
sir.
respond.
The same
Nothing.
problem.
The PDF? You can see a PDF?
No, sir. It's not visible. No.
Okay. Wait, 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 wait. Now? Now can you see my screen? Hello?
No, sir. It's not visible.
How can
No,
that
sir.
be? What you are showing?
No, sir. It's not visible, sir.
You are only showing the seeing
Uh,
the Google Meet window.
sir, but
Yeah.
no, sir. It is showing that Swastik Chowdhury is presenting, Chakravarti is presenting, but it's not showing the question, sir.
Mm. Others? Others? Are you? Can anyone else
Otherwise,
respond?
once you ask other participant, because there may be
Uh,
problem from my side.
huh.
Others, please.
Others, can you please respond? Anyone else other than Srinivas? Hello, Pratik, Sushila, anyone? Can you please respond whether you can see my screen?
Hello,
Hello, yes.
hello.
Hello, yes. Can you see my screen?
Yes, sir. Screen is visible to me.
The question, can you read the question?
हाँ जी.
क्या क्वेश्चन पढ़ पा रहे हो? कैन यू
Visible.
रीड द
Question
क्वेश्चन?
is visible.
Sir, it is now it is visible that whatever you write that energy signal with
Okay, okay, okay. Now, 1 minute. I will change the presentation mode. Uh, just 1 minute. Huh? Yes. Hmm. Varjot, is it? Hello.
yes sir.
Yeah. Can you see the PDF now?
Yes sir. It is showing that which of the following best describes an energy signal.
Okay. Okay. Yeah. 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 I think Srinivas, if you cannot see now, I think you have a problem at your end. Maybe you can rejoin
Yes, sir.
because it is visible now.
Okay, I'll do that.
Okay.
I'll do that,
Okay.
sir.
Okay. Okay. Yeah. So everyone else, this writing on the board is also visible, right?
Yes sir. It is also visible.
Okay. Okay. Fine. So I'll continue. Sorry for the disruption. So the which of the following describes an energy signal? So here I have written energy signal. Energy signal is the square. You take the smart square of the signal and you take an integration over it. Now this integration has to converge. If it converges, then only we can say that our signal is an energy signal. If it converges means it will stay finite. So integration means area under the curve will stay finite. So if we have a finite signal like this, if we have a finite terminating bounded signal, so it is terminating in some finite time like this, or maybe like this, or maybe like this, then these are all energy signals. Okay, these are all energy signals. Now, some signals can be infinite in duration, can be infinite. These are all finite duration signals, right? These are all finite duration signals. Hmm. So if these are all finite duration signals, then can we have infinite duration signals? Because these end, like these end, this one ends here, this one ends here, this one ends here. So these are all ending somewhere or the other. But can we have an infinite signal, which is energy signal? Yes, we can. If the signal's integration is converging, like an exponential. So if you integrate an exponential, you will get an infinite signal. Yeah, sorry, you will get a finite value because the integrate exponential is decaying. So if you integrate it, you will get a finite value. So this is again another energy signal. But in the same way, this one, this one is not a finite signal, not an energy signal. Why? Because it goes on and on. You just keep on adding the values. They are not decreasing with time. You keep on adding the values. So of course, this is not energy signal. This is not energy signal because it is not converging. It is constantly increasing. So this is not energy signal. So our first answer, our question, the answer is which of the following best describes an energy signal? The answer is a signal with finite energy over all the time. So the correct answer is option A. Okay. Now, energy signals must have finite duration to exhibit finite energy. So for an energy signal to have a finite energy, does it need to have finite duration? Is finite duration necessary? What do you think? Anyone wants to answer this? Please open your mic and answer. Anyone wants to answer this? If you want to have finite energy, like if you want to have an energy signal, is it necessary that they have to have finite duration? We just now discussed this. Anyone?
Sir, I think it is true.
No, it's not true. It's false. Here it is saying energy signals must have finite duration. But we have just now shown an example where the signal is not of finite duration, yet we have a finite energy, which is this one right here, this exponential, this one. See here, you see why you take an exponential. Hmm, you take an exponential. I will prove it to you. So xt, let's take xt decaying exponential. So xt, let's take e to the power minus t. Okay. So this is t, this is xt. So this is infinite in duration. Where does this exponential end? It does not end. It goes on and on and on, right? So it is infinite duration. It is not of finite duration. It is of infinite duration. But does it have finite energy? For it to be energy signal, it just has to have finite energy. It will have finite energy. How?
Sir,
Yes, yes, tell me.
yes, sir, it would have finite energy
Yes, it will.
because integration of exponential.
Yes, very good. So the exponential, the integration of exponential, I will just write it down for record like this. So from minus infinity to 0, it's 0. It only exists in positive. So 0 to infinity, e to the power minus 2t dt. Now it will just be e to the power minus 2t by 2 minus 2 infinity to 0. So this will become half. So the energy is half. So it is finite. So it is not necessary for finite infinite duration signals to have infinite value energy. It can have finite energy. So in summary, all finite duration signals are energy signal. All finite duration signals are energy signals. If it is finite duration, it will be energy, but not all energy signals have finite duration. Like in class 12 chemistry, you have read all alkalis are bases, but not all bases are alkalis. Like that. All finite duration signals are energy signal, but not all energy signals have finite duration. Some may have infinite duration, like e to the power minus t. So the statement that energy signal must have finite duration is false. It can have infinite duration. So the correct answer is false. Srinivas, now you can see the screen?
Yes, sir. Yes, sir.
Okay, okay. Now, in the second question, third question, sorry, if a discrete time signal xn is a power signal, which of the following must be true? So, signal xn is a power signal. Now we have encountered the concept of energy signal. So, what is power signal? Power signal means something that has a finite power. Power signal. Signal with finite power. That is the only definition. With finite power. Now, what is power? So, if you have a signal xt, if you have a signal xt, then power px is equal to 1 by t So here we see where t is time period. So here T is time period. So instead of calculating over the entire duration, we are calculating over a time period. We are calculating the energy, average energy over a time period and dividing it by time. So we are finding the energy over a time period and dividing it by time period. So energy by time is power. So here it is implied that there should be some periodicity. So power signal implies periodicity because we need to have the concept of time period. There are some exceptions where the signal, even the aperiodic, is a power signal, but we will not get into that. In general, we can say that power signal is periodic. So power signal, the concept of power signal comes along with periodicity. It's like buy one get one free. They come together. So like you have a sinusoid. Now, one second. Now, here this limit. Now this power that we have to calculate. What we will do is now which part to take, which part of the signal to take. So what we do is basically we take the limit t tends to infinity. So one second, please. So here what we do is power signal one condition is this power and it must have finite. Now where how to check whether it will have finite? We check the limit that limit t tends to infinity px should be finite. So that is the test. And along with that we have an auxiliary test that is limit not limit, sorry, that ex should be infinite. So this is an auxiliary condition. Usually when limit t tends to infinity px is finite, this is also holds true that auxiliary ex should be infinite. So it should have infinite energy. So something will have a bounded power but an infinite energy. It implies that it will go on and on forever. So if you add the areas, it will go to infinity, right? Because this sinusoid is going on and on forever. So these areas are getting added and added and added. But if we divide it by the time period, then we will have something which only concerns this time period. And this time period's power will be equal to this time period's power and this time period's power. Because it's like from one period to another period, the signal does not change. So this power should be finite. Power means the basically the energy power is directly proportional to the energy content within this segment from 0 to t. Whereas energy is the sum total of all these lobes. So of course Ex will be infinite and Px will be finite for sinusoids. Okay. Now let's prove for as an example, let's prove that sine t is periodic. Let's prove sine t is a power signal. Xt equal to sine t is periodic. So We have defined power as 1 by t minus t by 2 to t by 2 mod xt square dt. Now, when limit t tends to infinity, it should be finite. So, 1 by t minus t by 2 to t by 2. Now, what is mod xt? Mod xt is sine square t, because we are out there to prove that sine is periodic. Sorry, sine is a power signal, not periodic. Sine is a power signal. Xt equal to sine t is power signal. Okay, we want to prove this. Prove. So, mm, so we want to prove this. Now we will take sine t dt, and we have to take a mod square. Okay, so now sine is an odd function, right? So 0 to t by 2, it will be sine t, and minus t by 2 to 0, it will be minus sine t, right? 0 to t by 2, it will be sine t, and my 0 to minus t by 2, it will be minus sine t. But the catch here is this is mod square. So even if mod becomes minus sine t, the whole square makes it sine square t. So the minus eventually cancels out. So you will have sine square as plain as sine square. Now this will be 1 by t. Let's write this as px. This will be 1 by t. 1 to, now you modify this into 1 plus cos 2, right? I think not 1 plus cos 2. What is that? Half 2 sine square t. 1 minus cos 2t, is it? Cos 2t is 1 minus it. 1 minus 1 minus. What? I'm just forgetting. It's 1 minus cos 2t.
Cos 2 theta bro.
1 minus cos 2t. Right. So half into 1 minus cos 2t dt. So this one will just be t. So 1 by 2t. Let's zoom out a bit. Yeah. So yeah, this one will be 1 by t. You integrate this 1, it will give t. So t within limits t by 2 to minus t by 2 will give capital T. And you take the 2 outside. So it is capital T. And you integrate cos. Integration of cos will give sine. So sine 2t by 2. And this will be within limits minus t by 2 to t by 2. Now sine is a odd function. So when you subtract these two, upper and lower limits, you will get 2 into the same thing. So 2 into sine 2t. So eventually you will get t minus sine 2t. Now this is your px. For x to be sized, for x to be power signal. Now for x to be power signal, xt to be power signal, limit t tends to infinity, px should be finite, should not tend to infinity. Then, so limit t tends to infinity. So let's evaluate this limit. So what will be the limit? You take the capital T inside. So it is 1 minus sine 2t by t. So what will be the, what will this evaluate to? What is limit? So let's multiply 2 here and subtract 2, divide 2. So what is limit x tends to infinity sine x by x? Tell me. Not limit x tends to infinity. I think we are doing something wrong here. Is it? I think, yeah. Sine to t. No, 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 that should tend to 0. T tends to 0 is sine x by x is 1. X tends to infinity will simply be 0, because this will be this when t tends to infinity, this sine theta will remain bounded. This will be within minus 1 to 1, right? This will be within minus 1 to 1, but this will go to infinity. So the overall thing will go to 0. Understood? So it will just be half. So the answer is half. The power is half. And more importantly, it is finite. So it is a power signal. Now you can check for yourself the energy of, if you evaluate the energy of sine t, you will get it to be infinite. Okay. Because what will be the energy? The energy will be this sine square t within minus infinity to infinity. So if you put that, it will simply go to infinity, because you will have this cap t. You will have a t here, right? And the t will go to infinity. So the whole entire thing will go to infinity. So energy will go to infinity. We are in power. We are dividing by t also. That's why it is getting cancelled out, and we are getting a finite result. Okay. So energy, you can verify for yourself if you don't believe me, but energy will tend to infinity. So this is a proper sine t is a power signal. Like that, you will be asked to prove whether a signal is power signal or not. Okay. Now we come to the question. Till now we have just described the concept of power signal. So if a discrete time xn, okay, if you have discrete time signal, what will happen? Instead of integration, you will have summation. Okay. So if a discrete time signal xn is a power signal, which of the following must be true? See this one, limit n tends to, you see this expression, right? Let me point out. Pencil. Yeah. You see this expression, limit n tends to infinity, 2n plus 1, x n minus n equal to minus n. Summation n varies from minus n to n x n square mod. This expression, this one here, right here. This expression is the expression of power in discrete time. Power in discrete time. Okay. And this expression, summation n equal to infinity to minus infinity mod x n square. This is energy. Energy in discrete time. Okay. So B gives the expression for energy, C gives the expression for power. So which of the following must be true? So must means it is a necessary condition. Without it, you cannot say it's a power signal. And that is, then correct answer is C. For it to be a power signal, the main condition is that power should be finite. Everything else can wait, but the power should be finite. If the power is not finite, it is not a power signal. So if you ask for the strongest condition, then it is answer C. Option C. The average power must be finite. For a discrete time signal to be power signal, the average power, that is time averaged square magnitude, must be finite. Then usually mod xn square is infinity. B also holds true, but B is usually, means most of the time. Whereas C is must, it will always hold. It is the definition of power signal. A, a power signal can have finite energy, but a power signal can never have infinite power. Then it's not a power signal. Okay. So okay, the correct answer is option C. Now, if the Fourier series of the signal is given as, now we are coming to Fourier signal. So Fourier series. In Fourier series, you have two forms of Fourier series. One is expressed using sine and cos, that is the sinusoidal form, and another is the Fourier series where your coefficients are expressed in the exponential form. Okay, now we know that e to the power j omega t is nothing but sine omega t plus, sorry, cos omega t plus j sine omega t. Okay, we know that. So we can compress cos omega t, this one, and sine omega t into one single exponential, that is this one. That can be possible, right? Because exponential is nothing but cos and sine. So what are the relation between this an, bn, and cn? That is the question. Okay, now we can start from the exponential, yeah, exponential Fourier series, and then we can work our way uh, to the sinusoid Fourier series. Okay, so let's write the exponential Fourier series first. So the exponential Fourier series is given as xt is equal to e to the power minus 2 pi j nt by t. Okay. Okay. Minus j 2 pi nt by t, where n varies from minus infinity to infinity. Okay. So we have this exponential Fourier series. Now let's expand this. So we know exponential is cos plus j sine theta. Exponential theta is cos plus j sine theta. Cos minus 2 pi nt by t plus j sine minus 2 pi nt. So cos is a even function, so it will absorb the negative sign, whereas this one is an odd function sine, so it will be minus j. Let's take the cn inside the bracket, j cn sine 2 pi nt by t, and we can take the summation also, so n equal to minus infinity to infinity. Now you see this one we can break into two parts because there is a subtle difference between exponential and sinusoid Fourier series. That subtle difference is exponential Fourier series runs from n equal to minus infinity to infinity, whereas sinusoidal Fourier series runs from n equal to 1 to infinity. So there is a subtle difference. The exponential one uses exponential function and the trigonometric one uses trigonometric function. That is the thing that everyone sees. But the subtle difference is that there is a n equal to 1 to infinity here, whereas this is n equal to minus infinity to infinity. So this one only holds for natural numbers, positive numbers, whereas this is holding true for all numbers, all integers. Okay, their domain are different. So what we can do is we can split this. So into n equal to minus infinity to minus 1. We will do one part. Okay. This will be very lengthy, the expression. So bear with me. Minus, so plus n equal to minus infinity to minus 1. No, sorry, n equal to 1 to infinity Cn cos 2 pi nt by t. So I have done negative part, positive part, and then 0. What will be 0? If you put 0 here, it is cos 0. Cos 0 is 1. So C0. Now let's put the sinusoid part. So minus j summation n equal to minus infinity to minus 1 Cn sine 2 pi nt by t minus j n equal to 1 to infinity Cn sine 2 pi nt by t. Now you put 0. So positive part, negative part, 0. Here if you put 0, sine 0 is 0. So entire thing becomes 0. So it's just 0. Nothing is there. Now we have 5 terms. We can write like so. Now in this n equal to minus infinity to minus 1 parts, we can substitute a new variable called m, where m is minus n. So if n is varying from minus infinity, n for Nigeria is varying from minus infinity to minus 1, then m for Mumbai is varying from 1 to infinity. So here we can just write m equal to 1 to infinity Cm. Acha, what is n? If m is minus n, then m is minus n, then n is minus m. So this is C minus m. Okay. Now cos minus 2 pi mt by t. But there is no point of a negative sign inside cos. It's an even function. So it will just be cos 2 pi mt by t. Plus, we also have n equal to 1 to infinity. So we also have n equal to 1 to infinity Cn cos 2 pi nt by t. And we have C0. Now you see, we can, this suffixes, since this is a definite summation, we know the limits. So this suffixes doesn't matter. Having m equal to 1 to infinity and n equal to 1 to infinity is the same thing. So we can just substitute m equal to n. Right? And that's what exactly we will do in the next step. So let's first complete this step. Sorry. Array. Let's first complete this step. Minus j. So here we will again substitute n equal to minus m. So we will have m equal to 1 to infinity C of m. Now we have a negative sign inside sine. So what we will do? We will take the negative outside because it's an odd function. The negative will come outside. So minus will become plus. So C of minus m sine 2 pi mt by capital T. Minus j n equal to 1 to infinity Cn. Now what we will do is we will just substitute m equal to m equal to n, because the two variables, different variables, make the same sense. As long as it's a definite summation, it doesn't matter what your running variable is. So we can just substitute m equal to n. So if you have m equal to n, then these two become same, this summation becomes same, this cos becomes same. Only the difference will be this will be Cn, this will be C minus n. So you will just write like this: am equal to 1 to infinity, and there will be a C0 at front. C0 is there. M equal to 1 to infinity, rather not m, n. N equal to 1 to infinity, Cn plus C minus n cos 2 pi n t by t plus n equal to 1 to infinity, not plus, so yeah, plus j. So we will take j common. We will have C minus n minus Cn sine 2 pi n. Now this is the trigonometric Fourier series, right? This is exactly the trigonometric Fourier series. A0 plus summation n equal to 1 to infinity an cos 2 pi n t by t plus, if you take the j inside, rather let's take the j inside, plus summation n equal to 1 to infinity bn sine 2 pi n t by t. So if you compare them, what will be the result? The DC will be same. Let's do a one by one comparison. So C0 will compare with A0, right? So A0 is C0. So DC will remain same in all this. Now AN is Cn plus C minus n. And what will be Bn? Bn will be J into C minus n minus Cn. So let's find the correct option now. So AN is what? AN is Cn plus C minus n. Okay. So either option A or B. Now what is Bn? Bn is Jc minus n minus Cn. Jc minus n minus Cn. C. So the correct answer is option A. Okay. So this is how you map exponential and trigonometric Fourier series. Okay. Is this question clear for everyone? This one was a bit lengthy, so I hope everyone followed. Next, question 5. If the Fourier series of the signal is given by xt equal to this trigonometric series for any half-wave symmetric signal. So half-wave symmetric signal means that your signal, let's explain half-wave symmetry first before answering the question. So what is a half-wave symmetric signal? Half-wave symmetry. So in terms of equation, it is xt equal to minus xt minus t by 2. So a full wave goes from one time period to another, right? So like 0 to t, that is one full wave. We have one signal from 0 to t by 2. Now from t by 2 to t by t, capital T by 2 to capital T, the signal should be such that it is a mirror image. Understood? It is a mirror image. So it is like this. So this is a half-wave symmetric signal. Let's say this is 1 or a, whatever, next. Now it will repeat like this. This, this. This is a half-wave symmetric signal. Here this half-wave is symmetric with this half-wave. You can draw a line of symmetry between them. Now, which of the following quantity is identically zero, that is equal, always equal to zero for half wave symmetric signal? So if the signal has a period Fourier series like this, for a half wave symmetric signal, what will be the coefficients? Which coefficients will always be zero? So you try for what? This is question 5, right? Take 5 minutes. You try for 5 minutes, okay? Then we will solve. So please take down this question and try to solve it. After 5 minutes, I will ask. Okay, please try to solve it. Okay, here AN means all harmonics. Okay, A1, A2, A3, A4 like that. Whereas B2N means only the even harmonics. B2, B4, B6, B8. So AN means all harmonics, AN or BN. But A2N, B2N means odd harmonic, even harmonics. Okay. Okay. So please attempt this question. I'll be checking in 2-3 minutes. Then we can solve this together. Okay. Okay, I think we should attempt it now. So here we have to examine whether all harmonics are zero or even harmonics are zero. Okay, so what we will do is mm, we will first evaluate an. First, we will try to evaluate an, and from there we will try to get some pattern. So, what is an? An is 2 by t integration minus t by 2 to t by 2 xt cos 2 pi nt by t dt. I'm writing this correctly, I think. How? Yeah, xt 2 pi nt by t dt. Now, instead of minus t by 2 to t by 2, here you can do 0 to t because I have defined this half wave symmetry like so. Where did it go? Yeah, like so, from 0 to t by 2 and t by 2 to t by 2. So let's do that like that. So let's do like that. So it's 0 to t. Now we will split this into 0 to t by 2. Sorry, this will be t by 2 to t. Xt cos 2 pi nt dt. So this we have split. Now what we will do is we will substitute z is equal to t plus t by 2 such that z becomes, sorry, t becomes z minus t by 2. So instead of t we will substitute z minus t by 2. Now the limits will become, this one will become t by 2 to t because we are adding a t by 2. So this becomes xt plus t by 2, sorry, xz minus t by 2 cos 2, আরে এত লেটে কি আছে, cos 2 pi nt by, so this is your this signal after substitution, and similarly plus 2 by t. Now here we will have from here we will have t to 3t by 2, but half wave symmetry only holds for periodic signals. So here we will have t to 3 by t by 2, which will effectively be t by 2. So 0 to t by 2. We'll see that later. So x z minus t cos 2 pi n by 2. Now half wave symmetry the principle of half wave symmetry says xt is equal to minus xt minus t by 2. So this xz minus t by 2 will become minus xt. So an is equal to minus xz it will become, and cos 2 pi n by t z minus t by 2. Now this will become pi n. So cos 2 pi nt by t, 2 pi nz by t minus this whole thing t by 2 into 2 pi n by t. This will become pi n. So it is a multiple of pi. So you are basically subtracting a multiple of pi from cos. So if you do that, so like you are basically doing cos x minus n pi. Now what will you have? What will you have? So here cos x minus n pi. So for sine, it sine is x, sine x minus n pi will have sine x, cos x minus n pi will have, I think if I'm not wrong, minus cos x, but sometimes my trigonometric identities are wrong. So can someone just verify? It will be minus cos x, right? Can someone please just verify whether this will be minus cos x or not? So here it will not be minus x, it will be minus 1 to the power n x. Okay. So this will be minus 1 into minus 1 to the power nx. So it will be minus 1 to the power n plus 1 cos z 2 pi nt by 2 pi nz by t. Okay. Now let's put here. Here, as I have said, that we can always shift this by t and shift the limits, and it will be 0 to t by 2 because the period is t. So we can always do this. And we here also we will have minus xz cos 2 pi nt minus n pi. So again, this minus n pi will become minus 1 to the power n. Now, mm, okay. I have done one mistake. I'm sorry. The substitution should only be done in the first integral, not the second integral. So it will be t by 2 in the first integral, not in both integrals. Okay. So this should only be done in the first integral. So this one will remain intact, t by 2 to t. Let's erase this. This will remain intact as xt cos 2 by nt by t. Now, the goal here is to make these two terms identical. The goal here is to make these two terms identical. So, when one of them is negative and one of them is positive, they cancel out. Okay. So that is why you do substitution only in one part of the integration, not on the second part. So please amend the writing accordingly. So finally, what we have is an equal to minus 1 to the power n plus 1. Now this is z. This is in terms of z dz, and this is in terms of t dt. But you see, whether it is z or t, that doesn't matter. The running variable in definite integral is immaterial. So we can change the z back to t. We can just substitute z equal to t. So what we have is t by 2 to t xt cos 2 pi n t by t dt plus 2 by t. Again, you have the same integration. Sorry, same integration t by 2 to t xt cos 2 pi n t. Now, here, if you put n equal to even number, if n is even, then n plus 1 will be odd. If n plus 1 is odd, then this one will become minus 1. So n will become 0. Or in other words, a to n is equal to 0. So if the running the even for even harmonics, a is 0. Now for b, it's even simpler, because in b what you will do, you will follow the same tactics, but in sine you will encounter a sign here, sine x minus n pi. Now this will be just sine x. The sine x, and sorry, no, the sine x minus pi. Na? Yeah, this will again be minus 1 to the power n sine x, like this. So again you will have minus 1 to the power n plus 1, and again you will, by the same logic, you will say that b to n is 0. Okay, so by the same logic you will say b to n is 0. You can try on your own, but b to n will also be 0. So for even harmonics are not present at all. So no even harmonics. So both a to n and a b to n are 0. No even harmonics. Now consider the following signal as energy or power signal and find its value. So categorize the following signal as energy or power signal and find its value. So can you please tell me whether this will be energy or power signal? We have discussed just in the beginning of the class. Anyone who was there from the beginning of the class?
It would be energy signal.
It will be an energy signal. Exactly. Very good. Why? Because you see, what is e to the power minus 2t? It is a decaying exponential, right? There is no doubt about that. So it is going till infinity. But the area under the curve is finite. So it has a finite energy. It has a finite integration. So it has a finite energy. Okay. So this is a energy signal. There is no question of this being a power signal. Now what we have to do is find the value of what? Value of the energy, of course. That is not written, but that is implied. So xt equal to e to the power minus 2t for,
It would be 1 by 4.
it will be 1 by 1, how 1 by 4, e to the power minus 40, 1 by 4. Yeah, it will be 1 by 4. So let's show the calculations too. Correct, it will be 1 by 4. So xt is e to the power minus 2t. for t greater than 0 and 0 for t less than 0. Now, the energy Ex will be given as minus infinity to infinity mod xt square dt. So, minus infinity to 0 up to that it is 0 anyways. So, it will be just 0 to infinity. E to the power minus 2t. Exponential is always positive. So, the mod has no point here. So, e to the power minus 2t whole square dt. Okay. Is equal to 0 to infinity e to the power minus 4t. Can you tell me, just like this will be 1 by 4. Now I think it is very clear to all of you. E to the power minus 4t by minus 4, infinity to 0. So this will be 1 by 4. So the correct answer is 1 by 4. Energy 1 by 4. Option C. Okay. Now I have one question for you guys. Like a thinking question, not a solving question. That the energy is defined as minus infinity to infinity mod xt square. Now, can you tell me what's the significance of putting mod and xt? Mod and square, sorry, mod and square on xt. Because why do we need mod? To take only the positive values, right? But even if we take negative values, the square will make it positive. So if we want to only consider the positive values, the square is sufficient. Why do we need a mod? Is it necessary? And if it is not necessary, for which number set is it not necessary? Like in which domain is it necessary and in which domain it is not necessary? This mod. Can you tell me? Is it really necessary and where? This mod? Because in ordinary cases, you see this like this e to the power minus 2t, or you have like even if you have like minus 3, say minus 3, mod of minus 3 whole square. What is that? So 3 square, 9. But if we don't take the mod, just minus 3 square, what is that? That is still 9. So the mod has no effect here. So why are we putting a mod? Anyone?
Complex signals.
Yes, very good. So this mod is there to handle complex signals. For real, for all real, you can just write minus infinity to infinity x squared t dt. If xt belongs to real. If xt belongs to real. As long as the signal is in real domain, the mod is immaterial. The mod comes into play only when the signal is complex valued. The signal is complex valued. Then you will need the mod. Why? You see, if you take 2 plus 3j whole square, what is that? You take a plus b whole square. So 2 square plus 3j square plus 2 into 3j. So it is 4 into this. So 4 minus 9 plus 4 3 12 12j. So 4 minus 9 plus 12j. So minus 5 plus 12j. Whereas, see, we want to find energy and we are getting a complex number. That is not correct. We cannot have complex number as energy. Can we? No. Energy is a real quantity measured in joules. You cannot have complex number as an answer for energy. It's not. Uh, it's not valid. So if we take mod 2 plus 3j whole square, this mod is not about taking positive part. This mod is about taking magnitude. So this is root under 2 square plus 3 square whole square. So it is 4 plus 9, 13. See, this is minus 5 plus 12j, this is 13. Very different answers. But as long as it was real, you have no problem. You don't need the mod. The mod is redundant. Okay? Who answered this? Who answered this?
Srinivas.
Huh? You. Okay, Srinivas. Very good, Srinivas. So this one was a bit of a thinking question. Now we will go back to solving questions. Yeah. Which of the following statement is true about direct delta function? This direct delta function means impulse function. So which of the following statement is true about the impulse function? One is that minus infinity to infinity integration will be 1, and one is that delta t is 0 for all time, and another is delta t is infinity at t equal to 0, and another is delta t equal to 1 at t equal to 0. Which one is correct? Tell me. Okay, let's rule out possibilities first. Delta t equal to 0 for all t. That is simply not correct. It cannot be 0 at all times, right? That is meaningless. Now delta t equal to infinity at time t equal to 0. This is again not very correct. Why? Because this one gives a infinite value, a unbounded value. So we cannot do any kind of mathematics with this kind of an expression, which goes to infinity at t equal to 0. So again, this is not a well-defined function. So for a well-defined function, it cannot go randomly to infinity. So this has to stop. So this is not correct. Now delta t equal to 1. Now you might say that delta t equal to 1 is correct, which we usually take. That at t equal to 0, delta t is 1, and rest it is 0. Right? This is what we usually take. But again, this one actually introduces discontinuity. Why? Because we are assuming at t equal to 0 plus, just 0 plus, just after 0, delta t is 0. So delta 0 plus is not equal to delta 0. This leads to a right-handed discontinuity. Okay. So this leads to a right-handed discontinuity, that delta 0 plus is not equal to delta 0. So you cannot have that. So you want a continuous function. But then how you will define delta t? You will define delta t as option A. That the integration will be minus infinity to infinity will be 1. This is how you define delta t. Okay, direct delta function. So it is an impulse at t equal to 0. It is defined like that. But it's not exactly 1 at t equal to 0 only. It is 1 at t equal to 0. It is some intermediate value which is very, very small. It takes an infinitesimally small value at this delta 0 plus. At delta 0 plus it takes 1. After that it takes a very infinitesimally small value, such that like 1 plus the actual integration result will give 1 plus dx kind of. But since this dx is very small, so it will become 1. That's how you define, so that it remains smooth. So this is the next. Find the power of the signal a cos omega 1 t plus theta 1 plus a cos omega 2 t plus b cos omega 2 t plus theta 2. So this one is basically, you have two sinusoids. Okay. So if you have two sinusoids, how will you calculate the power? The power will be, okay, let's do a small math. It will be a square plus b square by 2, but still we will do a small math. 1 by t minus t by 2 to t by 2. A cos omega 1 plus t plus theta 1, b cos omega 2 t plus theta 2. Omega 1 t plus theta 1 plus b cos omega 2 t plus theta 2. This is how you do the integration. Now, whole square. Mod is not necessary because it's real, as we have discussed. So this is the power. Now 1 by t minus t by 2 to t by 2. A square cos a square omega 1 t plus theta 1 dt plus 1 by t minus t by 2 to t by 2. Same thing, but with v1. Now, the frequency and phase are immaterial for power. That you understand, right? What frequency and phase is absolutely immaterial because this cos will anyways vanish. So, what you will have is a square by 2. Here you will have a square by 2. Here you will have b square by 2. How? You will just multiply and divide by 2 and 2 cos square theta. You write it as 1 plus cos 2 theta, and then you will see that cos 2 theta term will go to 0 and integration will give you a square t by 2t. So t will cancel and you will get a square by 2. So these two parts are sorted. This is just basic finding the power of a sinusoid. And the power of a sinusoid, you can solve like this also. You take the a square outside, and what is the power of a sinusoid? The power of a sinusoid is half. So a square by 2. Okay. Power of a unit sinusoid is half. So a square by 2. Now, the tricky part is this multiplication. 2ab part. So for the 2ab part, minus t by 2 to t by 2, ab cos omega n t plus theta 1, and this one will be into cos omega 2 t plus theta. So this will give 2ab by t. Now let's evaluate the integral. Cos omega 1 theta 1 into cos omega 2 theta 2. Now, what is cos A into cos B? Let's take the 2 inside. What is 2 cos A cos B? What is 2 cos A cos B? Cos A plus B plus cos A minus B, if I am not wrong. Okay. So, my trigonometry is a bit sketchy these days. So, please correct me if I am doing some trigonometry wrong. Okay. So, yeah, minus t by 2 to t by 2. This is cos 2 cos A cos B is cos A plus B plus cos A minus B. So A plus B will give omega 1 plus omega 2t plus theta 1 plus theta 2 dt. And you have another part which is Srinivas, please mute your mic if you have nothing to say.
Sorry, sir.
Uh-huh. Yeah. So minus t by 2 to t by 2 cos. This one will just be omega 1 minus omega 2 t plus theta 1 minus theta 2. Now, this is cos. Cos is a even function. So, you integrate it, you will get an odd function. Huh? So, sine 2 cos A cos B, cos A plus B plus cos A minus B. Yeah. Okay. So here you have even function. Now you do a integration. Integration will give you odd. So here you will have sine omega 1 plus omega 2t. So sine t by 2. 1 second. Hmm. Hmm. Sine minus t by 2. Cos will give sine. Hmm. 1 second. Cos. So this will be sine omega 1 plus omega 2t plus theta 1 plus theta 2 by, so t divided by omega 1 plus omega 2, I think. Yeah. Now this will go from t by 2 to minus t by 2. The integration of cos is sine, and the integration of sine is minus cos. Okay. So t by 2 to minus t by 2. Now here omega 1 and omega 2 will actually have different t, I think. Same t কি করে হবে? Omega 1 plus. Okay, here sine omega 1, sine plus sine, maybe. Okay, so here one thing I have missed actually, that's why my calculations are not adding up. If you go back to the definition of power signal, I have said that to evaluate the power, we do is we check at infinity. Limit capital T tends to infinity. Okay, that is what is missing here. So here throughout this calculation of power, we will have a capital T tends to infinity, which I have missed. So here we will have a capital T tends to infinity. So this calculation is right, but we have to tend this to infinity. Now, anyways, the first two terms will be unaffected because the capital T anyways gets cancelled. So whether it tends to infinity or tends to zero doesn't matter. What matters is here, limit t tends to infinity. So here we will have limit t tends to infinity. Just add that. Okay. So here also we will have a limit t tends to infinity. The calculation is all right, but we will have a limit t tends to infinity. Now, if you look at the calculation, a square by 2 plus b square by 2 plus this thing is sine. Sine is odd. So it will just be 2 times. For t by 2 to minus t by 2, it will just be 2 times. Right? So plus it will be 2 sine, 2 into sine, because it's an odd function. So AB by T into 2 sine, let's put omega 1 bar as omega 1 plus omega 2 for short, and omega 2 bar as omega 1 minus omega 2. Okay, so this will be 2 sine omega 1 bar T plus theta 1 bar by the same logic divided by, sorry, capital T by 2 divided by omega 1 bar. Okay, plus the second integral that we have not done, limit t tends to infinity, AB by T sine omega 2 bar means omega 1 minus omega 2 T plus theta 2 bar by omega 2 bar. T by 2 to minus T by 2. So again, this will be limit t tends to infinity, AB by T two sine omega 2 bar capital T by 2 plus theta 2 bar divided by omega 2 bar. Now look at these two expressions. This is a sinusoid, so it is bounded between minus 1 to 1. This is always between minus 1 to 1. This is a frequency, so this is always finite. This is also finite. So this is finite, this is finite. This is a sinusoid, so it is bounded between minus 1 and 1, so it is finite. This is a frequency value, so it is finite. So this whole thing is finite. So this whole thing is finite. So if this thing is finite, then AB by T, AB is also finite. This is also finite. So everything is finite. Only 1 by T is infinite. T is infinity and 1 by T is there. So if T tends to infinity, what does 1 by T tend to? 0. So there is 1 0 multiplied by a few finite terms. So it will be, this whole thing will go to 0. Okay. So a square plus b square by 2 plus 0. Similarly, here you see, this is a sinusoid. So this is finite. It's bound to be. It's between minus 1 and 1. So it is finite. Omega 2 is a frequency. It is a frequency value. So it is again finite. But this will not happen if omega 1 equal to omega 2. If omega 1 equal to omega 2, then omega 2 bar equal to 0. Then you have 0 here. Okay, you have a 0 here. And you have a 1 by infinity, that is 0 in the numerator and 0 in the denominator. So you have a 0 by 0 form. So this will become something else. If we had omega 2 bar equal to 0, that is omega 1 equal to omega 2. And this will again become 0. So it will be a messy thing, 0 by 0. It will be, you have to evaluate the limit if omega 1 equal to omega 2. But in the question, it is given that omega 1 is not equal to omega 2. Omega 1 is not equal to omega 2. That is why it is given. So that omega 2 bar is not equal to 0. So this will become a finite frequency. And this is of course finite. These are just coefficients. So everything is finite, only 1 by T is there. So again it will become 0. So it becomes a square plus b square by 2. Is the derivation clear? So it's a square plus b square by 2. Anyone having any doubts in this derivation? Anyone? Yeah. Okay. If not, I have done this question. So Let's go to the next part. So when omega 1 equal to omega 2. Now we come to the part where omega 1 equal to omega 2. So we don't need to calculate again. No need to reinvent the wheel. We will just go back to our calculation, and from there we will try to find out what will happen if omega 1 equal to omega 2. Okay. So we will just get the answer from here only instead of reinventing the wheel. Uh, hmm. If omega 1 equal to omega 2, see omega 1 plus omega 2, this part will go to 0 because omega 1 bar, that is omega 1 plus omega 2, this will be finite anyways, always. So this will go to 0. This third term will go to 0. What will happen of the fourth term is of question. So limit t tends to infinity, ab by t sine omega 2 bar t by 2 plus theta 2 bar by omega 2 bar. Here, mm, hmm, t by 2 omega 2. Here omega 2 bar is equal to 0 and t tends to, rather tends to 0 for our calculation purpose. T tends to 0 or t tends to infinity. Sorry, t tends to infinity. So what will be the value of their product? Now the product of angular frequency and time we know is 2 pi. That we know. Now omega 2 bar of course does not have a time period, that is t. It might have something different. But eventually here we will take that this sine theta 2 bar. So eventually we will take that omega 2 bar and t. This will give some sort of multiple of pi because omega and t gives a 2 pi. So we will assume it will give some multiple of pi. Okay. So like that. Like that. So here we will take sine some multiple of pi. So maybe sine 2 pi. Just take 2 pi. Okay. 2 pi by 2 plus theta 2. Now this t omega, there is another t and omega product here. This will again give some kind of a pi. So we can say that we have a AB product here, and this sine pi plus theta 2, this will become sine theta 2 bar, sine theta 2 bar, and divided by 2 pi. Let us assume just that this 2 pi is absorbed in the AB. So AB by 2 pi is the new AB. So like that we can assume, and we can say that it will be, actually we are doing a very rough calculation here because we do not know the exact limit. Okay, the exact limit will be known if you know the omega frequency values. So here we are taking a rough calculation of sine theta 1 minus theta 2. So here okay, it's cos here. So anyways, the final result will be, which is a very rough calculation here, not an exact calculation as I said, will be a square plus b square, a square by 2 plus b square by 2 plus some AB term will be there, and there will be a sinusoid term, sine or cos, which will give theta 1 minus theta 2. So there will be a sinusoid term with theta 1 minus theta 2, and there will be a square by 2 plus b square by 2. So here you can choose the option, this one. Okay. Now, what is the Fourier representation of a square wave? This you will get in any standard textbook. Just search for Fourier series representation of square wave. It will be 4a by n pi. 4a by n pi. The coefficients will be 4a by n pi. Okay. So, and the even harmonics will be zero. Only odd harmonics will be there. So that is there. You can just calculate, find out from any standard textbook. Just find the Fourier series of square wave. I'm not doing this. Okay. So do it on your own or refer it from a textbook. So that concludes our class. We have solved today's assignments. And next week, again, Tuesday, 6 p.m. we will meet. Okay, thank you. Thank you. You may leave.
Thank you, sir.